Here's another example of how to subtract fractions. Now these denominators are a little bit more obvious with plus signs and minus signs that you need to use parentheses when you're factoring the denominator. Again, we have the difference of perfect squares. So we break down the first term, we break down the last term, and we check the signs. They're different. One's a plus, one's a minus, and that's a 3. So we want one common denominator, that's why I draw one line. And I first look to see what they have in common. They both have an x plus 3, so I write that down just once. And then I look to see if they have anything else left over, and this x minus 3 is what I call leftover. It wasn't common. And then I go back and fix the fraction so that they have the same denominator. This first fraction only has one factor in the denominator. It's missing a factor, and the factor it's missing is that x minus 3. So I put that both in the denominator and in the numerator, so I keep the balance. Taking a number and dividing it by itself is 1. Multiplying by 1 doesn't change anything. So using the distributive property, that gives me 7x minus 21. Now here's that subtraction again that we really have to be careful of. This denominator had two factors, has both of those, so it doesn't need any fixing. But this subtraction is to subtract everything in the numerator that follows. So I have to subtract the x, and I also have to subtract the 4. That's why I say beware of subtraction. You don't want to miss out on distributing the negative sign when necessary. Let's combine like terms. 7x minus x is 6x. Negative 21 minus 4 more is negative 25. And in the denominator, we still have x plus 3 and x minus 3. Now you're not done with your fractions when you add and subtract until you try and reduce. The way that you try and reduce is to factor the numerator. First rule in factoring is look for something common. Nope. Second thing is to count how many terms, just 2. When there's only 2, it needs to be either the sum of cubes, the difference of cubes, or the difference of squares. And this is not a square. So, there we have it, and we're all done.